Space. It might be wondrous to look at, but it's one of the most inhospitable environments imaginable. No sunscreen yet invented can protect you from solar radiation. And don't assume you'll be better off in the shade. At minus 150 degrees Celsius, it's colder than the Arctic.
I have the door. I have the door.
The lack of oxygen will cause you to lose consciousness within 15 seconds. While millions of micrometeoroids orbit the Earth like a cloud of tiny bullets.
Okay, thanks a lot, Greg. Copy, Stuart.
We got a great shot of Tom there. We can see his face very clearly. I thought he might want to wave to home.
So to protect astronauts from the hazards of space, scientists have created the nattily named EMU, or Extravehicular Mobility Unit. A spacesuit to you and me. And this amazing garment is so damn sophisticated, you need a degree just to put it on.
It doesn't look easy, but once you've done it a few times...
You can do it by yourself, but it just takes some practice.
Each suit is created from 17 individual layers, each one designed to perform a specific task. The first problem is providing a pressurized atmosphere for the astronaut to work in. Without that, in the vacuum of space, your blood would simply boil.
The decrease in pressure would have it basically boil out of your skin, and it would be very painful. So it would be a painful way to die if you didn't have that pressure.
So to make the suit airtight, the first layer is an air-retaining bladder made from polyurethane. And to prevent that from blowing up like a balloon, it's surrounded by a restricting layer made from neoprene-coated fiber.
Okay, Tom, he's leak-free. You can take him on up to 4.3.
But if they made the pressure inside the suit as high as it is on Earth, it will become almost rigid. So instead, every suit is designed to work at just 1/3 normal atmospheric pressure.
At 4.3 pounds per square inch, the suit is very mobile. The joints flex really easy, so it's not a high pressure, so the suit works quite well.
Additionally, the suit also uses special joints to help the astronauts bend their arms and legs.
So I have a bearing in the side, which gives me this rotation. Then I have a bearing that's at the end of the arm, and then I have my wrist bearing. I have a bearing at the waist, which gives me this flexion here. So I can work over here, or I can work over here.
Okay, I have the door.
Because the pressure inside the suit is low, breathing normal air would be a bit like being on top of Mount Everest. So, once in space, astronauts breathe pure oxygen, pumped into the suit via an umbilical cord. And in case this supply should fail for any reason, they also carry a 30-minute emergency supply in the bottom of their backpack. The problem is, every time the astronaut breathes out, the suit fills with poisonous carbon dioxide. So on their back, astronauts carry the primary life support subsystem, which filters the gases through a charcoal cartridge to remove any noxious vapors, then uses lithium hydroxide scrubbers to absorb the carbon dioxide. So now the astronaut can breathe, but there are still more problems. Back in the 1960s, the first astronauts in space quickly discovered that their suits became like saunas. The reason is that spacesuits have to be heavily insulated to protect the astronauts from temperatures ranging from over 100 degrees Celsius to minus 150. The modern EMU is heavily insulated with layers of neoprene, Gore-Tex and Dracon. But in the vacuum of space, body heat is lost very slowly, and so the solution is the liquid cooling and ventilation garment. This contains tiny tubes through which water is circulated.
This is your connector that takes the water in and out of the liquid cooling garment to the backpack, and it circulates it so you can cool it.
And no more than 100 degrees.
Finally, the outer layers of the suit need to protect the astronaut from micrometeoroids, minute particles flying through space at thousands of kilometers an hour. To stop these micrometeoroids tearing through the suit, the outer skin of the EMU consists of 7 layers of aluminized mylar, an extremely tough kind of polyester. Finally, there's one more outer layer, made from Gore-Tex, Kevlar and fire-resistant Nomex, the white top layer designed to reflect back the sun's harmful radiation. Incredibly, the finished suit is almost half a centimetre thick.
I feel great. It's nice and cool and nice airflow, and then also the temperature of the water is really good.
At a cost of close to $20 million, you might expect this suit to be tailor-made, yet bizarrely, nearly all of the components are off the peg.
See, on the other side we have the waist and the hut parts. Also, we have all the different size arms that the crew members may need. The back towards the back, we have all the different size boots.
Incredibly, just one part of the suit is custom tailored: the gloves. Creating gloves that will give the astronauts protection and yet simultaneously be flexible enough for them to work is a serious challenge for the suit's designers. The process is so complex, they cost $40,000 a pair and can only be used 25 times. The first task is to take a plaster cast from each astronaut's hand. This is then used to build an exact computer model. Next, they need to turn the 3D computer model into a mold. And just like a word processor, this computer simply prints it using a special 3D printer. This printer works by building up the shape layer by layer. The final result is a resin mold, which is then dipped in latex.
So at this point, I have 3 more dips that I have to put on of the latex. And then after that, I'll go to my polyurethane, which is the green dips.
The polyurethane is then cured under UV light. And finally, the outer layers are carefully sewn on top. This custom-made approach means the gloves fit the astronauts perfectly.
Good job on that. That was not much fun.
The EMU is an amazing piece of engineering. When an astronaut floats in space inside it, it's effectively an entire spacecraft. But with new missions to the Moon and even Mars being planned by NASA, work has begun developing new suits suitable for work on the surface of the planet. These hard suits are not only more durable than the EMU, they're actually more flexible as well, courtesy of these sophisticated new joint designs.
This is the Mark III prototype suit. One of its biggest differences is it's very much more mobile than the EMU is. You'll see that Kevin can move his shoulders up above his head, and he can also rotate at the waist. Both of those are very important for doing scientific exploration on the surface of the Moon.
Thanks to modern spacesuits, man can now live, breathe and work in the hostile environment of space. And whilst these suits might not win any prizes on the catwalk, at a cool $20 million a pop, they're not just more expensive than anything by Armani, they're a darn sight more sophisticated too.